When we have linear equations, we want to isolate the x, get x by itself, and here we need to get the sine by itself. So any ideas on how we do this? Yes?
Subtract the 1 to the other side and then divide by 3.
But you have signs on both sides. So it's similar to 3x plus 1 equals x. That could be the equivalent algebra function. So if you had this algebra function and you wanted to solve it, what would you do first? What? Subtract the sine x, this sine x, and bring it to the left-hand side. You can do that, but that's too many steps. So what I want to do is subtract 3 sine x. Doesn't matter which side the sine x is on. You get 1 equals what? Negative 2 sine of x. And now how do you get the sine of x by itself? We're going to divide by negative 2. So the sine of x equals negative 1/2. Now, in which quadrants is the sign negative? In quadrants? In quadrants, what? Not 2, but in quadrant 3 and 4. So the sign for which angle? Let's do the positive angle first, the reference angle. What angle are we talking about? For which angle is the sine 1/2 in the first quadrant? Without looking at the sheet that I gave you. The sine of x is 1/2 for 30 degrees or pi over 6. Pi over 6 would be the reference angle. Keep that in mind. Now we are in quadrant 3. So what is the angle in quadrant 3? 11 pi over 6 would be in quadrant 4. 11 pi over 6, and in quadrant 3, well, if the reference angle is pi over 6, we have 6 pi over 6 here, and then we have another pi over 6, so that would be 7 pi over 6. And since it does not give us the restriction from 0 to 2 pi, you have to add the period to it, so 2n pi plus 2n pi, because that's where it repeats. Guys, any questions here? What?
Why did you add 2 and pi?
That is the period. So the sine is negative 1/2 for every 2 pi. It repeats itself. So if we're here, oh, that's a cosine. Here's a sine. So that's 1 period. Then we have another sine. And then we have another sine. So that's 1 period, 2 periods, 3 periods. Negative 1/2 would be somewhere down here. So it repeats itself every 2 pi times. And we put an n there. N is an integer because it could be 1 and could be 1, which would be this one. If we make n 2, then we got to add 4 pi to it, and it would be over here. So the n stands for how many pi's, 2 pi's you're actually looking at your sine function. You always, like I said, if it is a general where you don't have a restriction, for sine and cosine, you always have to add 2n pi if it isn't a multiple angle. This is a single angle. We're going to go back to the multiple angles in a second. If it's tangent and cotangent, you have to write n pi. Any other questions? So that was just a review of what we have done last Monday, and then we solved some trig equations that had the form of a quadratic equation, and this one is the one we looked at. You factored all the ones that we worked with, they can be factored. Then you set each factor equal to 0. So here we have the sine of x negative 1/2 again, so 7 pi over 6, 11 pi over 6. For which angle is the sine negative 1? That would be 3 pi over 2, and these are our answers. Here we do not write plus 2 and pi because the book told us to do it between 0 and 2 pi. So here we have a list of angles that has to stop at some point in time. Any questions here? Everybody good? Definitely questions that are on a test. Now let's talk about multiple angles, this problem. And it's called multiple angles because this says 3t, so 3 times the angle of t. The way you do that is, first of all, you disregard that 3t or 3x, whatever it is, and you are solving for the trig function. So you're solving for cosine here. How do you do that? What is the first step? You want to get the cosine 3t by itself. You add the 1 to cosine 3t equals 1, and then what do you do? Divide by 2, and you get the cosine of 3t equals 1/2. Now let me, I don't think that's in the book, but let me say we want to find all the angles from 0 to 2 pi. Okay. So now the first step that we're doing is we're looking at, again, we're disregarding the 3. We're looking at all the angles for which the cosine is 1/2. The cosine is positive in quadrants. Which quadrants is the cosine positive? 1 and 4. All students take calculus. 1 and 4. 1 and 4. So the way we write this now is we're going to say 3t equals, and the angle is 60 degrees or pi over 3. That would be quadrant 1. What is it in quadrant 4? 3t equals 5 pi over 3. Now, what I'm going to do here is I'm still going to add plus 2 and pi. And I'll show you in a second why am I doing this. Okay. So, now we're not interested in 3 times the angle, we're interested in t. So how do I get t by itself? Now I have to divide by whatever value is in front of that variable. So we're going to divide by 3, which is really the same as multiplying by 1/3. T equals, if we multiply everything by 1/3, that's pi over 9 plus 2 n pi over 3. T equals pi over 9 plus 2 n pi over 3. If that restriction wasn't there up here, 0 to 2 pi, you would be done now. that would be your general angle, and you would be done. So because of a different period here, 2 pi over b, remember, the period for this cosine function is 2 pi over 3. Well, that's why we have to add this here. Now, every 2 pi over 3, this angle, or this value, 1/2, repeats itself. So now we got to find the rest of the angles that are between 0 and 2 pi. Since our least common denominator is 9, and I always like to write that up here because then we can see when we stop. The restriction is really 0 to 18 pi over 9. I want to keep it the same denominator. Once your angles are larger than 18 pi over 9, then you got to stop. You got to think about that. 2 pi, if we have a least common denominator of 9, has to be 18 over 9 because that is 2 pi. So we had the first angle, so let me make my list here. The first angle is pi over 9, and hold on, 5, I forgot a 5 here, right? Guys, why don't you say something? 5 pi over 9 cannot be the same, okay? Now we're going to find the other angles. Now we're going to make n equals to 1. N is equal to 1, we get t equals pi over 9 plus 2 pi over 3. Which means, like I said, the least common denominator is 9. So that is pi over 9 plus 6 pi over 9, which is what? 7 pi over 9. Now we're going to do the same thing over here. 5 pi over 9 plus 6 pi over 9, which is 11 pi over 9. So that is still within my 18 pi over 9. I'm going to erase some of it. Now I'm going to do it again. I'm going to use n equals 2. I'm going to erase this one here. So if n is equal to 2, we get pi over 9 plus 4 pi over 3. Well, if we make this the same denominator, that would be 12 pi over 9. So pi over 9 plus 12 pi over 9 is 13 pi over 9, which is still smaller than 18 pi over 9. And we're going to 5 plus 12 pi over 9, that would be what? 17 pi over 9. And now guess what? We're actually done, because the next, if we were to make n equals 3, then we get 6 pi over 3, which is 18 pi over 9, and would be outside of our limit there. Another way you know how you can stop, well, we have two angles in quadrant 1 and in quadrant 4, but we need 3 times those two angles. So 2, 4, 6, you have to have 6 angles now. Whatever this number is, that's how you're multiplying your original answers to, and you need to come up with 6 angles. You can't see that 17. 17 over 9, let me write it over here. How do you like that? do another one. Let's see if I have another one. Not this one just yet. Let's add one to it. Solve multiple angles. Okay, let's do this one. Number, I don't know, 39, why not? 39 in the book says 2 cosine 2x minus 1 equals 0. And this time you have no restriction on the domain. So this is just general angles. What is the first step? Add 1, so 2 cosine 2x equals 1. We've done this already 5 times this morning. So the cosine of 2x is positive 1/2 now. We bring down the 2x, for which angle is the cosine positive 1/2? We just did it. Pi over 3. And 2x equals what? 5 pi over 3 in quadrant 5. So now, general form, plus 2n pi. This is through 3t. Now we're doing the 2t plus 2n pi. How do we get x by itself? We don't want to know 2x, we want to know what x is. What do we have to do? We multiply everything by 1/2. So now our angles would be pi over 6 plus n pi, 5 pi over 6 plus n pi. Done you are. And in this case, we would get 4 angles if they were between 0 and 2 pi. This was almost the same in the other one. Let's take a look at, let's go back to, not this one, but 44. 2 sine x over 2 plus square root of 3 equals 0. Now what? How do you get sine x halves by itself? What's the first step?
Subtract the square root of 8, as I said, and then divide by 2.
Thank you. So sine x over 2 equals negative square root of 3 over 2. Okay, and this time we have 1/2 of the angle, so we get x over 2, for which angle is the sine negative square root of 3 over 2. Anybody? The sine, first of all, is negative in quadrant 3 and 4. The reference angle for square root of 3 over 2 is 60 degrees, pi over 3. Pi over 3 is your reference angle. Always go back to the reference angle. So if you are in quadrant 3, then the angle is 4 pi over 3. And in quadrant 4, the angle is what? Anybody? 5 pi over 3. Plus 2n pi plus 2n pi. Now, how do you get x by itself here?
Multiply by 2.
We're going to multiply by 2. So that gives you x equals 8 pi over 3 plus 4n pi. Over here we have x 2 times 5 is 10 pi over 3 plus 4n pi. And again, there was no restriction here, so you would be done. Now, if you had to find more angles, and you go from 0 to 2 pi, in this case, you would multiply by 2, and you would have to stop at 4 pi. Just trying to erase it. There you go. You want to find all the angles or another one? Let's see if we have one in the book that says in the interval from how about one more? How about 63 or using that may be the ones that you don't get exact answers. Let's just try it. I want to see what happens. 63. 63 says 2 sine squared of x plus 5 cosine x equals 4. We haven't had a problem like this where you have sine and cosine. You have something squared, but you cannot use, at least just yet, the factoring or quadratic formula because we have different variables here. So how do I make them the same? That is something for calculus you have to know. You have to integrate or differentiate this problem. They either all have to be sine or they all have to be cosine. You can't have mix and match here. Which one you think is easier to change, the sine squared or the cosine? Yeah, I have no idea how to change the cosine. There's not real, you can make it 1 over secant, but that's not going to help you. So the sine squared is written like what? Isn't it like 1 minus cosine squared? I think it is. Okay. So 2 times 1 is 2 minus 2 cosine squared x plus 5 cosine x equals 4. Now we have like a quadratic equation, so let's rearrange and see what else we can do here. Negative 2 cosine squared x plus 5 cosine x and bring over negative 4, so that is a negative 2, set it equal to 0. Because we want to see if we can factor it. What mathematicians absolutely don't like is when it starts off with a negative. So let's change the signs here and multiply by negative 1. So this becomes a cosine squared x minus 5x, I almost said, minus 5 cosine x plus 2 equals 0. Quadratic equation. If I put the algebra plus u equivalent, it would be 2y squared minus 5y plus 2. Can I factor that? 2y, the 2 and the y here, they both have to be negative, right? 2y squared, negative, here we go. That's it, right? Yes. So this can be factored as 2 cosine x minus 1 and cosine x minus 2 equals 0. -4 minus 1 is a -5. Where did I get the problem? 63. Solve the equation. So if we set each factor, this is fun stuff. I like that. I could do that all day. That's cosine x equals 1/2 and cosine x equals 2. Right? Are you with me? Okay, now we're doing it again. Cosine x 1/2. How many times did we do that this morning? For which angle is the cosine 1/2? Pi over 3 plus 2n pi, because it doesn't tell us to stop. And it is also positive in quadrant 4, and that would be 5 pi over 3 plus 2n pi. How about cosine x equals 2? For which angle is the cosine function equal to 2? Inverse, you can use your calculator. Inverse of 2. What do you get? I hope you get nothing. The angle or the inverse cannot be larger than 1. Our angles, our trig functions are between negative, this is the y value, between -1 and +1. This side is not possible. Cross it out. NP, not possible. The cosine cannot be equal to 2 for an angle. It's between -1 and +1. So guess what? Here are your answers. Guys, practice. Questions? Okay, we're going to move on. 5 points. Sum and difference formulas. Did everybody get the formulas? Everybody got one? Cameron, you got one? Oh, okay. They're also in the back of your book. So now we're getting into the formulas. Why we're using them? Because we can rearrange, and we use the sum and difference formula to find exact answers for angles that are not the common angles. If you have exact answers for 30, 60, 45 degrees, and their multiples, 90, 120, and so forth. But how about 75? How do we get the exact trig value, the exact value for the sine of 75? The sine of 75 is not one of our common angles. So what we're doing is we're using the common angles and we're putting it either as a sum or a difference. Like for example, 75 could be rewritten as 30 plus 45. And 30 and 45 are what we know, so we're going to use the sum formula, like for the sine of 45 plus 30, and figure out that way what the value is. So we're going to use it for angles that are not common angles. Now here are the formulas. You also have them on your handout. That's really something you should memorize. The sine of u plus v. So u plus v are our angles. And what happens with the sine is you multiply sine u cosine v, and then the sum is the same as here on the other side. We have also plus, and then we switch the angles. With the difference of two angles in the sine, they have the same sign in the middle. While the cosine, sum and difference, it's cosine u, cosine v, they have opposite signs. So plus changes into minus, and the minus changes into plus. And then you have the tangents here. U and v, of course, are your angles. So we're using them to find exact values for functions that are not 30, 60, 45 degrees multiples. Okay, so let's practice this. Cosine of pi over 4 plus pi over 3. Now put the formula down here again. This is the sum of the cosine. So if we say this is u and this is v, now we're going to rewrite the problem. That would be the cosine of pi over 4 times the cosine of pi over 3 minus the sine of pi over 4 times the sine of pi over 3. So now we're finding our exact values, and this time, guys, sometimes when you take the test and it says you need exact values, some of you give me decimals, and there may not be the people that are sitting here. You cannot use decimals. Decimals are not the exact values. So exact values, if it is an angle, either in terms of pi, and if it is not, if we're finding the angle value, you have to use the values that are here on your sheet. So the cosine of pi over 4 is what? Square root of 2 over 2 times the cosine of pi over 3 for the 5th time this morning is 1/2 minus the sine of pi over 4 is also the square root of 2 over 2, and the sine of pi over 3 is what? Square root of 3 over 2. And we're going to multiply. Square root of 2 times 1 is square root of 2 over 4 minus square root of 2 times square root of 3 is square root of 6 over 4. Sometimes it's written like this. Now this book usually combines the numerator and writes square root of 2 minus square root of 6 all over 4 over a single denominator because the denominators are the same. So that is using the sum and difference formulas. But, she gave us the values already. It's kind of easy. All we have to do is plug it in. Well, some of them are, others are not. So we're working our way up. Are you ready? Now, what about sine of pi over 12? That is a problem, I'm sure, in the book somewhere. Sine of pi over, there's a negative pi over 12. It doesn't really matter. The sine of pi over 12, you have to rewrite it into two of our most common 30, 60, pi over 6, pi over 4. Now, if you're not sure, okay, how can I split pi over 12 apart? I don't even know what pi over 12 is. Change it into degrees. That's an easy trick to figure out how to find a sum. Let's change the pi over 12 into degrees times what we do. It's a good review for the final. Pi over 12 times what? 180 over pi. So the pi's are reducing. 180 divided by 12 is? Can be 180 divided by 12 is 15. So pi over 12 is 15 degrees. How can you represent 15 degrees? Say that again. 45 minus 30. Right? These are the two that we know. So that means the sine of pi over 12, we're going to rewrite it as the sine. 45 degrees is what? Pi over 4. 30 degrees is? Pi over 6. Here you go. So if you come across a radian, angle that you're not too familiar with and you don't know how to split it into angles that you know, change it into degrees first and go from there. So now we're going to use the formula. The sine of pi, you have this is a difference here now, so that would be, if this is u and here we have v, today is the first, right, not the second. Okay, because I just saw my doctor call me. The sine of pi over 4 times the cosine of pi over 6 minus, now I always write the sine first. The formula in the book says the cosine comes first, but that's just me. I'm so used to writing the sine of pi over 6 times the cosine of pi over 4. It doesn't matter which order you write them, but that's how I learned it. And if I'm just weird on certain things, if the sine comes here first, I want the sine first on the other side too. It makes no difference. Okay, what is the sine of pi over 4? Well, that's the same as the cosine, square root of 2 over 2. Cosine of pi over 6 is what? Ladies and gentlemen? The cosine of pi over 6. Pi over 6 is 30 degrees. That's the square root of 3 over 2. Minus the sine of pi over 6, which is 1/2 times square root of 2 over 2. So we get the square root of 6 over 4 minus the square root of 2 over 4. There you go. That is the exact answer. No decimals. If you were to use your calculator to find the sine of pi over 12, you get some kind of decimal approximation. That's the exact answer. What time do we have? Okay. What else are we going to do? Let's see. A tangent. 13 pi over 12. A tangent, 13 pi over 12, that's kind of number 19 here in the book. Number 19, you have to find all of them. 13 pi over 12. Again, that's not a radian angle. If you're familiar with, let's change it to degrees. What did we say? 12 goes into 180 15 times. 13 times 15 is what? $195? Yes? Okay, 195. How do we change this?
I have a question. Wouldn't it have been 12 times 15? Because wouldn't the pi's cancel out?
Yeah, the pi's cancel out.
Oh, sorry.
No, you, okay. That's right, yeah. 195. What angles do we have that we can use?
150 degrees plus 45 degrees.
150 is one of our common angles, right? Our exact angles, 150 and 45 degrees. So this becomes 150 plus 45. What is 150 in terms of pi? 5 pi over 6. And that would be pi over 4. So what we have is the tangent of 5 pi over 6 plus pi over 4. Tangent formula. This is u, and here we have v. So the tangent formula is the tangent of 5 pi over 6 plus the tangent of pi over 4, 1 minus tangent 5 pi over 6 tangent pi over 4. Okay, let's get to work. What is the tangent of 5 pi over 6? Tangent of 5 pi over 6. Does anybody have the handy dandy? Tangent of 5 pi over 6 is? Negative square root of 3 over 3 plus the tangent of pi over 4 is 1. 1 minus negative square root of 3 over 3 times 1. Do the math. Fractions, same denominator. So, negative square root of 3 over 3 plus 3 over 3, what is that? Complex fractions, remember when you done them? At some point in time, negative square root of 3 plus 3 over 3. Because out of the 1 we make a 3 over 3. And here we have 3 over 3 plus square root of 3 over 3, which is 3 plus square root of 3 over 3. Can I fit it in here? Cosine of u plus v, which is the sine of u is negative 7 over 25, and the cosine of v is negative 4/5, and both of them are in Q3, quadrant 3. So the formula for the cosine u cosine v minus sine u sine v. We have the sine of u, we have the cosine of v. What we don't have, we need to find. Quadrant 3, sine of u is opposite, negative 7. This is u, this is 25. So to find the adjacent, that would be 625. Let me use a calculator. 25 times 25 is, I need to bring a real calculator, the phone. 625 minus 49 is 576. The square root of 576 is what?
24.
That's what I thought. 24. And I write 25, but I'm going to do the same again. We're still in quadrant 3 with code recording 4/5, and of course this is 25 minus 16, this is 9, so this has got to be 3. And this is actually a negative, and this will be a negative. Okay, so the cosine, what angle is that? V. I don't like the V and the U. They look the same. The cosine of U is negative 24 over 25. The cosine of V is negative 4/5. minus the sine of u, negative 7 over 25, times the sine of v, which is negative 3/5. Here you go, sine of v, negative 3 over 5, okay? 24 times 4 is 96 over 125 minus a positive 21 over 125. (96) minus 21 is 75. That can be reduced, at least by 25, duh. That is 3/5. That should be our answer. Let's make sure. 47.
Is it always going to be cosine on the side?
For the cosine sum function, yes, it is. Yes, yes. Okay, we're going to stop here. And that is indeed the answer. Watch the video on this. I think there are some videos posted on here. Make sure that you understand these. These are important. We do a similar procedure for the double angle formula for sine and cosine as well. Okay, guys.